In this video, we will going a small discussion related to our derivative function. That was already explained to you that for any change in variable y with respect to variable x, the derivative function is defined by this quantity dy by dx. Now it is equal to what limit function, again we will write dy upon dx is written as the limit function in terms of the small change in the value of y with respect to the small change in the value of x, where this x delta x the change is approaches to 0. So this is the function, derivative function, and is defined by this equation. Now you have to understand some formulas, basic formulas related to this derivative function for certain quantities. Let us take as one by one. For any constant c, suppose you have to take derivative with respect to t here, time here. You are using the quantities of time basically in terms of, in case of velocities, displacement, speed. So we have taken here the change with respect to time t here for the particular formulas. Now for let us suppose we have to take a derivative of a function c, constant value c with respect to time variable. So that will give us the value as 0. You have to remember it first. Now if we have this c constant with multiplied by this t, suppose you have the function in terms of t. So when you take the derivative of this function, which will be defined by this equation, then this results in what? This c quantity remains here, and the function for differentiation of this t will be written as like this dt and by dt. Here we have take common c outside this differential function. So basically this remains to be c, since these both eliminate and will result in 1. So the differential function for an particular variable, suppose t, into may multiple of constant value c. But you have to keep it in mind that for these are the changes with respect to time t only. So in that case only the differential function results in constant c. Now take the third case, where you have a polynomial or exponential function, that is t raised to power n is given, and you have to find the derivative of this term. So it will result in this value. It will be written as, so let's see here, d upon dt of exponential function of t raised to power n will be written as, we will write this power n outside this quantity and then start writing this value t here, and the power will be decremented by 1. Suppose you have t5 and you have to take derivative of t5, then this quantity will be written as 5t4. The power, the exponent is reduced by factor by the 1 quantity, that is result in 4. So for case of 6 here we will take this as 6t5 and so on. So basically you have to remember these formulas for understanding the numerical problems.